Hello everyone, I am Dattatreya Nikam. Welcome you all on our channel eFunda for new day, new topic. And our today's topic is little different. That is weight and COG in instrumentation and control part 1201. As this video will be published in part so as to cover the entire range of a discipline for topic of a weight and COG. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos created on a various engineering topic and published in parts, and same are published on our channel eFunda. And if you are new to our channel, then don't forget to subscribe to our channel and press bell icon to get the latest notification on upload of our new video on our channel eFunda. Also, eFunda team has created membership option. Just you have to press the join button and get the details of every membership and their benefits so that you can have a privilege of being a eFunda member. So let's begin with our today's topic, that is the weight and COG in instrumentation and control part 1201. As this topic is new, so we are covering or starting with a basic understanding to the project teams and designer. This mainly will divide into the weight and center of gravity. Weight refers to the gravitational force exerted by instrumentation and control component due to their mass. One can refer to the picture where the mass and the gravitational force activities are shown in the figure. It is typically measured in terms of kilograms or a newton, which mainly include all physical items such as field instrument, that is a transmitter and a gauges, control panel, that is a PLC, RTU, failure control panel, cabling and a trace, tubing, fittings, JBs and mounting accessories, and the last one is a telecom and FNG equipment. Accurate weight estimation is very critical from the structural design and a transportation and a lifting arrangement point of view. So the weights are to be precisely included, and this is a thumb rule where you can approximated weight can be used and the rounding of the values to be done so as to have the complete load or weights on the typical structure or platform or a module or a structural part. Now center of gravity, that is a COG, is the point in a system or object where the total weight is considered to act. For an assembly or a module with a multiple IC components, the COG helps to determine balance and the stability of the structure. In simple terms, COG is the balance point of all combined weights into the system. Now it is important to understand the mathematical definition of a COG. COG height is equals to summation of a Wi into Hi divided by summation into Wi, where Wi is the weight of the component in I, H is the height of a component I from the reference base. The COG can be calculated along with the multiple axes of X, Y, Z or a full 3D system view. This is how the basic is important to understand by every team member to evaluate this activity during detail and design engineering. Introduction to weight and COG in instrumentation and control. One can refer to the below table where we can see the various elements. First, weight and COG estimation is crucial for module skid layout, lifting and several or structural design. One can refer to the first picture where the stable equilibrium and unstable equilibrium of the items are shown, where A refers to the center of gravity at the center, whereas for B, C and D one can see how the torque are applied and the center of gravity is changing. That is why it is called as unstable equilibrium. Second, instrumentation items often appear minor individually but contribute significant cumulative weight. Third, Equipment like panel, trays, tubing, and field devices affects COG vertically and laterally. Last one, early estimation avoids surprises during fabrication and lifting. One can refer to the second picture where the crane is used to lift the pipes are required to install at the plant site. As you can see, the height of the arm, lifting arm, and the gravitational force acting on the G1 G2, that is a CG, center of gravity, as shown, and accordingly the figures is being sketched and presented for better understanding. Importance of a weight and a COG in instrumentation and control. We'll see the detail. First, why weight and COG matter in instrumentation and control. Ensure proper load distribution in skids and structure. One can refer to the first picture where the point load, load path, weight distribution, and potential structural failure are shown. This is how the load distribution is important. Second, influence lifting lug design, crane selection, and rigging plans. Third, affects the seismic and dynamic behavior of offshore onshore modules. Fourth, supports safe transportation by maintaining balance and preventing tilting as well. This is why the weight and COG are important. Second, key contributor to INC weights. First, field instrument, that is a transmitter, PT, TT, LT, FT, local indicator, solenoid, etc. Control panel like PLC cabinets, RTU, welded control panel, analyzers, etc. Mounting hardware, stanchion, supports, manifold, tubing, fitting, cable management, FRP, GI trays, ladder trays, junction boxes, etc. Telecom equipment, CCTV cameras, IP phone, telecom racks, and cabinets. Hydraulic components like welded control panel, accumulator skid, and a pneumatic panel, etc. Also, one can see the second picture where the balancing is done and how the topside facilities is being installed on top of hull, riser, tandems, and foundation. This is why the weight and COG are critical and it plays an important role in instrumentation and a control discipline. Best practices and summary. We'll see the detail. Before that, one can refer to the two pictures where the complete floating assembly or the structure is shown, where the weight optimization of a frame steel structure are shown with the different types of elevation of each deck are mentioned. It is better to if include INC weight early in 3D model and GA drawing. Second, coordinate with the structural for support load and lifting plan. Third, maintain weight and COG register during design update. Fourth, use vendor data sheets for exact weights and mounting. Fifth, factor in 10% contingency for installation hardware. The last one is the effective weight planning. Ensure safer, more efficient fabrication and transport purpose. This is how the best practices are being implemented during the 3D modeling, where it will give the exact size of a weight or the dimension or the center of gravity, so that it will ensure smooth lifting and transportation of a control module. Now moving on to the instrument item weight and COG summary. This table is for ready reference where one can see the categories, item description, quantity, unit weight, total weight, and the COG height is mentioned. As you can see the category of a field instrument, various types of a field instruments are shown with their quantity, actual weight, and their COG. Similarly, tubing and fittings are also included, supports and accessories, then the cable trays, junction boxes, control panels, and telecom and cabling parts and their individual weights are mentioned, that the total weight quantity are being calculated. One should study this table carefully so as to understand how the weight requirement is covered, and we'll see further how the actual weight COG calculation is being done into the our next slide. Now weight and COG activity sheets, one can refer to the first picture where one can see the description, net weight, contingency, gross weight, center of gravity, and individual remarks if required are mentioned. Weight data input, there are several areas are marked: area 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., where is net weight, gross weight, and their individual center of gravity xy coordinates are being also mentioned, and this sheet is being populated. The calculation for doing such type of a sheet requires marking on the layout. One can refer to the second picture where one can see the various areas are being marked starting from second, third, fourth, fifth, sixth, and seven, where all the item falling to the respective area based on their category of a field instrument, cable trays, tube fittings, and then cable tray support, etc., are calculated in particular area where the area marking is being done, and the total weights based on the previous instrument slide where the item weights or total weights are mentioned are being applied to the respective areas. For area weight calculation, area 2, area 3, area 4, 5, 6, 7 weights are being calculated, and those weights are mentioned and included into the tabulated sheet for better understanding. This is how the weight COG activity sheet is being prepared, and the same activity sheet as well as the layout marking to indicate the area will be shared to the respective discipline where they are compiling their weight COG report, and this will help to have estimation or a load analysis for the structural item.
With this, we are concluding on our today's topic. Thanks for watching our channel eFunda, where you'll get to know the fundamentals. So that is our tagline: get your fundamentals right, where we do identify the needs, then we evaluate the need, then define plan for particular need, and then accordingly execute the plan. This is what we are creating our technical videos, so that it will help every individual to get their fundamentals right. And if you are new to our channel, then subscribe to our channel, and don't forget to press bell icon to get the latest notification on upload of our new video on our channel eFunda. Also, you can follow us on our Instagram page, and do follow our Facebook page as well. So keep watching our channel eFunda for new day, new topic.